time at SILA. I've been a LVOOP developer since the early 90s, and pretty much been my whole career with LVOOP development. And one of my, I guess, fairly recent projects, when I finally took the plunge into OO programming, which actually was about 4 years ago, I ran into a lot of trouble because I wasn't experienced with OO, and this talk is really about one of the more complex things that I had to solve and how I solved it. And hopefully the idea here is to give you some ammo so that if you run into the same problem, you don't have to go through the pain and suffering I did at the time. So if I get a little loopy though, by warning, I've only had 4 hours of sleep because I had an early flight, and I can say at least now my watch is ended. So what is this issue all about? So there's a very large number of architectures out there that uses messages to pass data between applications. Active Framework obviously being the most popular one, but several people have kind of rolled their own, I guess. I fall into that category. I kind of chosen and stolen from everyone else and made a version that I like for my application. And that's where I encountered this problem. It also will happen when you're using a plugin-based architecture. So if you're developing a system and you have a whole set of plugins that you want to be able to work on those when the application that runs them is not loaded in memory, you're going to run into problems if you're accessing functionality within the applications from within the tokens. And lastly, if you're trying to build reuse code that uses classes, and you want to isolate that reuse code, so again, it can access some core functionality that your application will implement for it, but you don't want the application to be resident in memory when you're editing that reuse code, and it also allows you to pass the reuse code around a little bit better. So first, I've given this presentation to a few different groups, so I want to ask, who here is not familiar with OOP programming? Okay, I might go through some of these a little bit quicker since most of you seem to understand it. I have a bunch of, actually almost half the presentation is to get you to understand the concepts, and then dive into the real problem. But I'm going to go over that a little quicker because last time I did this, I almost ran out of time going into all the details. But we're going to talk about some core concepts of OO, and these all come together to form the solution for this problem. So inheritance, abstract and concrete classes, what the factory pattern is, what dependency inversion is, or dependency injection. Those are somewhat similar but related. And so again, if you are not familiar with all of these, please raise your hand and I will spend a little bit extra time on those. But if everyone's heard of these, we might be able to move along a little quicker. So I've got one person. Okay, I'm going to go over pretty quick then. And I apologize. Feel free to come see me if you want a more in-depth description. But I'm probably not going to go through all of the code demos for all of them. It saves some time. But first, I do want to recommend a few books. This book actually was recommended by our previous speaker, Stephen, many years ago to me, and it was a great book. It really, really helped me get my brain wrapped around OO programming from more classic LabVIEW. Obviously, none of the examples in this book are in LabVIEW, but if you can read any text-based language, you can probably get enough from the examples to understand what they're talking about. And it's not really that important to read through their examples. The text itself is relevant. For understanding design patterns, like the factory pattern we mentioned, this is the go-to book, basically. People may refer to it as the Gang of Four book. You've probably heard it before. So I recommend pick up that one. And the last one, if you want to understand the solid principles, this is something that Dimitri has spoken of at NIWeek many, many times, and I've basically learned from him and also from Stephen about these concepts of software development. And this is a book that they're always recommending everyone to pick up. So just to give you a little background there if you want to learn more. So inheritance. So Parent class defines common methods and interfaces that are public, accessory data, and the child overrides those. The child has access, though, to what the parent has created. So your child is expanding upon what the parent already does. And that gives you the ability to extend functionality. And of course, the child class travels on the parent's wire, which is how the dispatch feature of LVOOP works. So you have the parent wire, the common class running through your application, and then different children can run along that wire. And then when you execute the parent method, you execute action of the child method has been overridden. And I'm going to skip the demo on this one because this is a pretty basic piece of OO. Abstract classes. All right, so an abstract class has no methods. Well, that's the common definition. But in LabVIEW, we really don't have the ability to have a truly abstract class. So my definition is it's a class whose methods must be overridden. So it has methods, but they're just blank BIs, or they can actually have whatever the template is that gets put on there when you create a method. But the code will never execute is the concept of this abstract class. So every single child that inherits from it overrides every single method in the parent. And I say mostly here because, like all rules, there's always exceptions, and I have actually broken this where I have found cases where there is a useful method you can implement in the abstract class that all the children might want to use instead of having to re-implement it over time. But what we're trying to do here is we're trying to define a common interface without including any specific implementations. So we're saying there's going to be these methods, but we're not telling you how they're going to work. We're just saying that they're going to exist in every single child that you create. And then concrete classes. So if you have an abstract class, to make it do something, you have to have a concrete class. So this normally, sorry, gotta catch up my notes here. So I printed out all my notes because I can't see them on my screen and I forgot to turn the page. All right, so this is where the actual work is getting done, in the concrete class. So the code that you're implementing to do your functionality. And they're overriding that parent method we talked about. That's why we call it the concrete class. These classes will be statically linked to any other code or classes that they call in their methods. This is the key problem that we're running into here, and why the solution works. When I get to it, what it is doing here to solve this linking problem. But code that actually implements something and actually calls other methods, calls or sends other messages within your system, is going to be statically linked to those things. And the factory pattern. All right, I'm actually going over the demo of this one. So this is basically how the message handler works. So Queer uses a message-based architecture in their code. So we all probably written a message handler or used one from Active Framework, seen that. And it's basically the factory pattern. You're using dynamic dispatch to execute the messages that come in through the generic message handling code. And then they run the concrete class, the actual child message that was sent to you. And then the implementation is contained within there. Let's see. All right, so I'm going to go over the demo on this one. I think this one might actually be worth it. The other ones were just really for absolute. Is that visible to everybody? I had to change the resolution on here so it would work. All right, so simple factory pattern. This is a very, very simple demo. I'll show you how it works. First, you put in a couple numbers, and you can add them, get the result, you can subtract them, get the result. And all that we're doing here is we're choosing which class, which child class, we send in to the parents execute function. And if we look at the code for this, we have a interface class, which is our parent, and it has a perform operation, and it does nothing. So this is the abstract class. And then we have a subtract class that overrides the perform operation with an actual implementation. We also have the add class, which also overrides it, the actual implementation. And that's all it really is. It's that simple. So okay, so dependency inversion injection. This is where we get a little bit more complicated topics. So the D in the solid is dependency inversion. And I highly recommend everyone take some time and learn all of these principles, because I ended up using almost every single one of these principles without knowing what they were, without knowing they existed. And then when I went back and learned all this after attending many sessions here at NIWeek and other LVOOP training, I discovered that I had actually done all of these things by accident, and I didn't know it. And had I known about them, I probably would have been able to solve problems quicker. But the key thing about dependency inversion is you want to make your code dependent on those abstractions and not the concrete code. So we want to, when we're executing, we want to be calling the abstract method, but we're going to inject a dependency, and this can be done at runtime, which is the key point. It's not necessarily statically determined. And then that injected dependency is what actually gets executed. And we need to provide a way for the system to reference this concrete class. And this is where the injection part of dependency inversion in my head comes in at least. So we use a concept called composition. So instead of inheritance, where you have a child inherited from a parent, composition is where you have a class that contains another class as part of its data. And in this case, we would be composing our system, and it would contain our abstract class, and then that would be what we would wire through our code and what we would be calling. But at runtime, we would be injecting a child of that abstract class, a concrete class, and then that would be the actual code that gets run at runtime. So let me show a quick demo of what I mean by this. So here we have a application class. So I consider this kind of like my overall system. And then I'm injecting into it a concrete class at an initialization point, because this can be loaded from disk. This can be done via a initialization routine, however you want to do it. At some time later in my code, I'm going to read this class from the application, and then I'm going to call a method, but I'm going to call this abstract method. And then it's going to execute the concrete method inside this class. So just to show you, there's the abstract class, again, shown in green, has no implementation. So that's what we're actually calling here. And then our injected class actually has an operation in it. It's just adding or incrementing number. But if we put in a number and run this, you can see that it increments. So it's calling that concrete class, our concrete method from the concrete class, even though we're telling it to run the abstract one. So I made these examples really simple because I'm just trying to get the concept across. I mean, I know almost everyone in this room already knows most of the stuff, but just to get it at the top of mind so that when we get to the solution, you can see where it all comes together. And again, composition is a class using another class, so that was our application class being composed of that injected class. And again, you can load it at runtime and inject it. This is what I normally do with, say, plugins. You're going to choose the plugin based on the configuration file, and then at runtime, you'll load that plugin class in, and then you'll store that in your system, and then you'll call the functions out of it. And the demo is basically the same as what you said. All right, so the message handler. Again, as I mentioned earlier in the beginning, the basis of most actor architectures is a message handler. It's kind of the heart of the whole thing. It's the key piece. In the past we had our few message handlers that we started with, and then we moved on to actor framework, and essentially they're all basically the same concept. It's just a loop that's monitoring some kind of a way of sending messages to it, and then when it receives a message, it executes the methods inside of that object. So each message in most of these systems, all the data that the message uses and all of the actual code that executes are only in child classes. So that abstract class for a message really has no concept of data elements. It simply has a do or a run or an execute method in it that will be overridden by the child. Which means that to send a message, you need that child class, because the child class defines the data payload, and it also defines how to execute the message. And this type of message handler, which is what AF uses, is called command pattern. And it has some benefits and some drawbacks. I've had many arguments with people about whether this is the right way to go or not. But why do I use it? Why do I like this method, and why is it in active framework? Well, it's because it gives you a strict type def of your message data. So this means that when you're composing the message to send, you can't accidentally put in the wrong data. Instead of it being a flattened string or a variant or something else, and I've used all those in the past, you're forced to give it the right data type. And this means that you're going to reduce your runtime errors, because you're not going to try to decode this message at the other end and find that it doesn't match. It won't unflatten because the wrong data was sent. So for me, that is a benefit. Again, a lot of people argue against that. It encapsulates all behavior in a single class. So if you're trying to understand what this message is all about, you can both see the data, and you can see what it's going to do with that data when it gets executed, all in one place. You don't have to look in two places. With, say, a string-based message system, you usually have the place where you execute your message is a case structure that could be 100 layers deep if you have 100 different types of messages. And navigating through that, I find, is difficult, and kind of puts everything in one place for every single message. And it also, I think, it harms reusability a little bit. But again, these are my opinions. I have some very highly respected library programmers I worked with for years who prefer to go the other way. And there's no reason that you can't do that too. But if you want to go with command pattern, these are the reasons I do it, and then this is what the talk is really about, how to solve a problem that command pattern introduces. And again, this is kind of the crux of the whole thing, is when you execute the message, you're going to incur this statically. The message itself, the payload data that's coming in, you need to know what that payload is to create the message. And then when you want to run the message, you need to access everything that the message does. And since these messages are being executed within actors or independent loops, threads, however you want to talk about them, they need access to the private data of the actor so that they can make changes to it. So they need to be able to read that state data. So the key thing here is that if you're going to have a message that you're going to send from point A to point B, the sender has a copy of this class, and this class contains the definition of the data, and it contains what to do with it. The receiver is going to run the method within this class, and then that method is going to need to be able to access the state data of the actor, which means it will be statically linked to the actor process. And it'll also need access to any messages that it might decide to send out as a result of being executed. So just to show a simple application, we have a single actor, and then we have a simple message. So let me give you a demo of this. Okay, so here we have and this is using my framework, so it's not going to look like AF, but it's very similar in concept. But we've created an application, we've created an actor, I call them processes. We've given it a transport, a means of receiving and sending messages, and then we've run the actor, and we've given it a name, and then at the end we destroy it. But all this does is simply increment a number. So it's a very simple application. If you look inside, let's give you an idea of what it looks like. We have our message handler here, and then I have a simple loop handler in the UI. So there's not a whole lot to this. I'm using an event to pass data back and forth. The more interesting bit is in the messages. So I will show you the message that's actually being used here. So here we're just incrementing the number, and then we're passing the value that we're incremented back to the UI. And this is the thing I was talking about with static links. So be able to access the actor's private data, the state data of your actor. You need a static link to the actor so that you can then access that data. And if we look here at the actor itself, you can see that this actor has the numeric and it has that event, user event. This is private data. And if we didn't cast our generic actor to our specific actor, we would not be able to access it. So that's the key reason we have to do this. And again, if you look at actor framework, it's exactly the same thing. In every message, we need access to the actor's data. You have to cast the generic actor to the specific one in order to modify that state data. And now that message is linked to that actor. So if you load the message into memory, you have to load the actor. And that's kind of where the problem starts. So, the message needs an instance of the actor to access private data. When you load the message into memory, the actor gets loaded into memory. The sender that's sending the message to you will need an instance of the message class to construct that message, because it needs to be able to access that payload that we talked about. This loads the message class in memory from the sender, which loads the actor in memory, which, if that actor sends other messages, then those messages can load in memory, which loads their actors in memory, and so on and so forth. So that's really the thing that I ran into. And I was developing this client-server application where I was basically taking a non-OO-based application that was one monolithic application. I was splitting it into two. And I was going to have a front end. I was going to do all the model view controller things that we've been learning about over the years, and have my view over here, and have my, all my business logic in a separate application. And lo and behold, I got halfway into this thing, and I realized when I tried to send some messages across the network that I opened up my application, and the entire code base of the other application became a dependency. So this was the real problem. This was the thing that took me a while to figure out. And the reason why I'm doing this presentation is I tried to explain this to somebody else after I had solved it a few weeks later at a meeting of there's a thing called the Center of Excellence. It's a group of LabVIEW-based or companies that use LabVIEW that we get together in different cities around the country. And one that I belong to in Seattle, we got together, and I was trying to explain this to everybody because I said, this is amazing, I figured this thing out, and here's how I did it. And I realized this is not trivial. And this is, everyone was like staring at me glassy-eyed because I was up on the whiteboard for about 5 minutes. And I think I finally got through to most of them, but I don't know how useful it was to them, unfortunately, because they probably weren't trying to solve the same problem. Anyway, so how did I fix this? How did I break these things? Well, this is where the abstract class comes in. So what I basically did is I created an abstract execution class. So as we said, all these messages have their do in them, or their execute, or their run, or whatever you want to call it. The thing that actually gets executed when the message arrives at the receiving end. And what I did is I created a separate class, and inside of that class, I put the actual execution code for all of my messages that I'm sending from one application to another. So I took them out of all the messages, and I put them into one class, and I'll call it the execution class. So there's an abstract version of that, and there's a concrete version of that. And so that means in this class, there is a method for every single message that's going to be crossing this boundary. Now, you don't have to do this for everything. You only have to do it for the messages that are going to go between your applications, and we'll get to the reason why later. So it's not like you have to do this for every single message you ever write, obviously, because it adds a little bit of overhead. But you'll have a method for every single message that's crossing your boundary, and the sender will only need the message class and the abstract version of the execution class. So they'll need the message class where we talked about you defining the payload and it's statically defined so that you don't have your runtime errors. And they'll need a copy of this abstract execution class, which is, again, a whole bunch of methods with nothing in them. And then the receiving application is going to still need the message class because obviously it needs to have access to the data types, and it needs the abstract class, and it needs the concrete class. And it's the concrete class that is statically linked to the actor. So we moved the static linking out of the message classes, and we moved it into the concrete version of this execution class. And so it's only in one place. And therefore you keep it only on the side that's receiving the messages. When I've done this in my application, I'll actually have a single abstract class for all the messages go both ways, and then I'll have a smaller concrete class on either side, so the messages that go from A to B, B has concrete information for just those methods, and ones that go from B to A has concrete methods for those, so they get smaller. So it isn't as bad as it sounds. You're not bloating your code too badly. But this is really how it looks. And I think this slide, more than anything else on the presentation, kind of encapsulates the whole idea. So you've got all your messages, you've got your abstract class, where you're executing each of these messages, and then you've got the concrete implementation, where the real work is done. So we're kind of pulling this all together, all these ideas that I was going through pretty quickly at the beginning to explain how this works. So let's take a look at another application here. So I'm going to, so this one has two messages, and one of them, I used this abstraction to break the link. The other one I didn't. So if you look at that one, we'll close out this one first. All right. So here we've got our increment number, but we also have the decrement number. So you can see it functions. What we've done is we have this shared class up here, where we have our abstract execute message class, and we have our decrement number class. So we're sharing this message with both the sender and the receiver. And if you look at the shared message, actually, let me stop this. What we're doing here is we're calling the abstract method. So instead of it actually having the coding here that would be statically linked and everything, we're simply asking our application, hey, at initialization, I gave you this abstract, this class that's of type abstract. It's actually the concrete class. And I want you to read that value out, and I want you to call this abstract method my do. This is the actual call to the, what was the do method. All this would have been your do VI in Active Framework. Now it's accessing a global variable, for lack of a better term, and then reading out the value that you loaded at runtime, casting it as the abstract class, and calling the abstract do method inside of that execution class. And let's go look at that because it's so here is the thing that's actually being called that you saw in that block diagram, and it does nothing. But what we did here is we put the concrete class into our global, application memory at the beginning, so that later on, this class is what actually comes out of here on this wire. And then when we execute that, we're not executing the abstract class. Instead, go find where I just, okay, in here. We're executing the concrete version. And here's the concrete method. And again, it just decrements. Remember, here you have your static link. So only that concrete class that you only loaded at runtime on the receiving application has a static link. And just to kind of demonstrate what this would look like, and what the problem looks like when we run into it. I've got another application here, and this application has nothing in it at this point. And I'll show you what's in the dependency, nothing in the dependency tree. If I go over here and I take the one that I haven't used this trick on, and I'm just going to copy this code. I'm just going to drag it over here. And you can see here, well, this code only uses proc1, my after proc1, but it pulled proc2 in. And it pulled in, all of these other decrement number, which is part of proc2, increment number 2, that's part of proc2. It pulled everything in, and that's the problem you run into, is you end up having all these links that you didn't want. And if we go in here to the message, and I kind of made this. I kind of faked it by putting this link in here just to demonstrate, because what I wanted you to see is that this message turns around and calls another message, which is sending to the other application. Well, if we get rid of that, all of those dependencies go away. And that's the key thing. We're trying to get rid of those dependencies in our other application by breaking these links. Does that make sense? Is anyone totally confused? Or I hope I've given this enough detail. And this is my third time giving this presentation, and each time I've tried to improve a little bit. So what we're just looking at, and I guess I should have gone in the slide first. So we had the application 1. Sorry about that. Ignore that you saw that. We'll get to that in a second, but hopefully I'm not running out of time. Actually, I'm doing pretty good on time. So we have this complex application, and we've broken this link by using having the message refer to the abstract method and having the concrete version injected in at runtime. so that if application 1 wanted to send the decrement number to tell process 2 to do the decrement number, it would get a copy of the decrement number, it would get a copy of the abstract message, and it would be able to send that over to the network. It would not need this, so it wouldn't have this link here to our actor that's actually going to do the work. And that's the key. So why are we doing this? Well, as I said earlier, if you're building multi-application designs where you're going across the network, this is required. And I'm not saying that this solution is the only way to do it, but this is the solution that came to mind when I had to solve this problem. And I've seen several other people basically do the same thing. Again, plugin architectures, you want to keep those static links out of the main application. So let's say we're writing a plugin. The plugin needs the ability to access some functionality inside of your application. It needs to be able to tell the application to do something while the plugin is running. Or maybe it accesses a database or something like that that's part of the main application. But if you use these abstract links to break the static link, then you won't have to have the main application in memory when you're editing plugins. This would mean that a team member working on a plugin doesn't have to have this huge amount of code base loaded into memory at the same time. And this makes it a lot easier to work on. And of course, reusable components. You can have abstractions inside the reusable components that when your calling application can implement different variations of. So it might be your reusable component says, okay, now write this to disk, but I don't care how you write to disk. The main application knows that I've got an abstract write this to disk method. I call that, and then however the application decides to implement writing to disk or writing to database or posting on Twitter, whatever. Casey did a great presentation of this. It might have been at last NIWeek. I know it was at the CLA Summit. And his presentation is more about reusable components, but he uses this concept that I'm using kind of as a part of it. It was more of an aside of his presentation, I thought. That's why I wanted to make a presentation focused just on this concept. So I would recommend highly check out his presentation. It's very good. Okay, why wouldn't you do this? Well, obviously, as you can see, it makes things more complicated. Now, instead of just having a message, now you have a message and an abstract execution method and a concrete execution method within your own classes, and you have to manage all this. So that means if you add a new message, you've got to create the concrete class and the abstract class to go with it. And as I said, I limit this to just the messages I'm passing across the board. If the messages are staying within the application, there's no need. So if you have one monolithic application, you're building a single executable and everything is already in memory anyway, this doesn't buy you anything at all. I mean, obviously, when you edit those actors, everything loads into memory, but most of the projects, everything's in memory anyway, so it doesn't really matter. It doesn't give you any performance improvements. So that's it. Anyone have any questions, or want me to go over something again? Did that make sense? Show of hands. Everybody, did I do a good job? I hope. Does anyone raise your hand if you think this is useful to something you're working on right now? Well, that's good.
Could you compare what you showed to those references? Or how we would
I think they're very similar. I don't use Active Framework, so I can't really talk in depth about how they implemented that. I just briefly looked at it a couple of years ago, and I had already solved it this way, and so I wasn't going to go back and redo it. So I wish I could give you more than that, but again, I wrote my own actor-based architecture around the same time Active Framework was coming along, and so what I kind of did in the early days was I stole a bunch of stuff from Active Framework, but I stole a bunch of stuff from, I think it was called Jamma, because I have subscriptions in mind that have lifetimes, and something can write to a subscription and it can go away, and then something else can come later and grab it.
Yeah, so I actually wrote down that you mentioned, and I'm giving a talk on Wednesday at 2 o'clock that's kind of more and more abstract than this, in terms of it's aiming for a less expert audience.
Okay.
But I'd love to have you come and talk with me, or I mean,
I'd love to
give me feedback on it.
Yeah.
After you take a look.
Let me know what time. I'm not sure I'll have it on my schedule. Yeah, so I stole from that one because I needed this concept of a subscription in my system. I also stole from the Aloha framework in that mine is a kind of a bus system. In other words, all my actors are peers. None of them, there's no hierarchy. They're all on the same playing field. But then I allow you to create lower level buses that can then implement hierarchy. And so I may have a application, and then I have a test system basically that has to have, I have to test n number of units simultaneously, and it's all asynchronous. So every time you say start a unit, it spawns an entire test executive essentially from the same code base and runs the test for that one and reports it back to the top level screen. So I'll create a separate bus layer for that application. And then I have plugins, which are my test modules and such and so forth. So it's many layers down. But I basically, like I said, I was coding this from a non-OO based application, which was all queue based, and it was all producer consumer. And I was in that mindset when I wrote it. And so I'm like, how can I turn this into OO? And this is what I came up with. And it's worked really well. The thing I like about it particularly is you don't have to have everything be dynamically loaded. You can actually make a VI, and you saw, and some of these examples, they were very simple examples, but you can actually still have a diagram with a bunch of different actors on the diagram. You can see how they interrelate and how they get launched and such. Whereas with Active Framework, everything is dynamic. Now, I still do dynamic as well when necessary, but I didn't want that to be the default. It just was easier for me, and that's why I went that way. Any other questions? So a few more minutes. Okay, well, thanks for coming. Oh, one more question. Go ahead. Yes, the second. So there's a single class of abstract methods, and those methods map one-to-one to each message. Actually, let me just pop back to that slide because that would be really helpful to see.
Can you repeat the question?
Yeah. Let me get to the slide real quick. And then, so the question was, do you have a separate class for each execution of the message? No, you have a single. Well, you could break it into multiple if you wanted to. Then you have to implement a system to tell it which one to choose. So I wish I had a laser pointer. My application is told about, is designed to work with this class. At runtime, we tell it this is the concrete version you're going to use. And each of my messages that I wanted to break the linkage on, instead of having the normal do VI, it has the VI that says, go run that one. But read this class out of the initialized memory and actually run that one. So if you look at this code, you see this VI on the diagram from this class, but this is the one that's going to get executed via the dynamic dispatch. So does that make sense? Does that answer your question? Anyone else? Yeah, go ahead.
Unlike other product lines, like C# or Java, your class is also for other languages,
Right.
If we have a class group of one, we can choose the query language one if we want like other data flow.
Right.
Is there any way to get rid of this?
Yes. That's a good point. So when I was describing the architecture I have that thing I call the bus. So that I call it's my system class. And I wrap this class in a DVR, a data value reference. And that essentially turns it into a by reference class. And I just pass that around to my entire application. So every part of my application has access to this DVR, and inside that DVR is information like what's concrete class we're supposed to be using here. So anything that you would consider global in scope to your application, you can implement inside of that DVR wrapped class. And we used to use single element queues to do this in the past before we had DVRs and classes and such. And then we moved on to the DVR method. And the nice thing about it, when you wrap a class with the DVR, you can still call the accessor VIs on the DVR directly. You don't have to dereference DVR inside of an in-place structure, but you can if you want to guarantee that you have a mutex around the thing you're changing. So whenever I'm modifying data that is, I don't want anyone else to read or write while I'm doing it, I'll use an in-place element structure around my system class, and I'll make those changes inside of that. But if I'm just reading something that I just want to know what is the value right now, what is the concrete class that I need to use here, I can just use the property nodes to read that directly without, it's what's the term, syntactic sugar, I think is what Stephen always says about it. It just makes diagrams cleaner. But yes, so you can do by reference. I think there's another presentation this week about how to do by ref in LabVIEW. You might want to look that one up. I remember seeing it on the site, but I'm not sure who will run it is though. But I mix both together. I mean, I try to stay data-based as much as possible because the compiler is more efficient that way. But there's lots of cases where you need to do it by reference and do mutex to protect the data. So DVR is your solution. Anyone else?
So by combining all these messages into one class, that creates a different kind of event because that then displays modularity here.
Yes, I know. And so instead of the 100 deep case structure, you've got possibly 100 methods in one class. Yes, that is absolutely true. But like I was trying to kind of allude to, you only got to do it for the messages that go between the systems. So I have hundreds of messages in my application, but I have maybe 20 that go between the client and the server. And so those are the only ones I had to do this to. And it wasn't that painful. Once I've done it, I really don't go back and add much more. Once you define kind of your API interface between your two applications and you've implemented all this, you're pretty much done with it. And then the benefit is you don't have the linking problem. And I mean, like I said, there's probably more than one way to skin this cat, but this is what I came up with. And it's worked really well. This application's been running for years now. It's a very large app. I mean, somewhere around 15,000 VIs, I think that last count, if you add the client server and all the plugins together. It takes a very long time to load each of these in the memory. That's why I'm not going to demo that. And I literally can go and get lunch while I compile this thing now. But it works, and it's been robust. I haven't had any issues. This works. Anyone else? Yeah.
Have you looked at scripting that operation?
Yes, and I'm a moderately okay scripter. I have mostly my scripting is kind of code review stuff. I clean up my code with scripts that I've written. But what I've done is I stole the clone class from Goop, and I use that one. So I have a template message, and then when I want to make a new message, I'll just load that one up, and then I'll tell it to clone it, and then I'll rename it. And then I actually wrote some scripting to clean up the copy that it makes. You got to be careful though when you use that method, because if you clone a statically linked message, the way Goop does this, it starts another application instance, and it does the cloning over there, and then it moves it over here. So that application instance, if you're cloning a message you didn't break the links on, it's going to load your entire application's code base into that thing, and it takes like 10 minutes to clone one class. So But again, that way I didn't have to write my own. And I would, if I had some minions working for me, I would say go forth and create all these wonderful template creation tools for me. But I don't, so I live with that. And it's been okay. I really do wish I had some of the cool stuff that AF has, and I've actually thought about maybe I should just go rewrite something in AF, but I just not good at that. Anyway, but thanks for that.
So you mentioned going over network.
Yeah.
So somewhere I'm guessing you're doing flatly one byte. What kind of network do you take?
Okay, I'm going to admit this. Don't at me, but I use VI Server, and I literally just have it open the VI on the destination, and it just takes the object right in directly. And I always intended to replace that. And I said, well, this is just for now. I wrote this like 6 years ago. I will get rid of this. And I looked at network streams, and I looked at all these what's those zero MQ, and you know what? The VI Server still works. I don't give a damn about the security issues in it, frankly. It's the hardest part is getting the frickin' IT guys open the firewall ports. But once you get that done, it's done. Well, of course, then they keep deleting them all the time. But the worst one was I work remote a lot, and I have to VPN in, and getting them to allow me to have a connection back through the VPN to my desktop running the client to the server running it in the server farm. That was a nightmare. It was like, you should never do that. That's not how things work. I'm like, dude, it's bi-directional, peer-to-peer. It's not a web page. Please just open the port. So, but yes, that's how it. And I would love to show you guys the code for that. It is kind of gnarly looking, and it has a lot of weird little things I had to learn along the way to make it work right. But the nice thing about it is it using some switches to tell if it's in the exe or in the development thing, I can actually open both projects, the client and the server, and then run them, and then have them talk to themselves on my desktop. And when I build them, it converts all the code to work across the network, and it just works seamlessly. So, and sometimes the old methods they still work. Anyone else? I think we're probably almost out of time now. If you guys want to just come and ask more questions, that's fine too. I'll be here for a few more minutes. Thanks for coming.